This section is called Proportionality and Similarity, Changing the Scale. In this section, we aim to understand the concept of proportionality and how a change in the dimensions of a figure affects its area or volume. Example 1. A lemonade recipe calls for the following ingredients: 1 part sugar, 3 parts water, and 1 part lemon juice. What are some combinations of sugar, water, and lemon juice you might use to make this recipe? Since the recipe is not specific about how much sugar or water or lemon juice we use, we can begin this recipe using any amount of sugar. Let's suppose for this example that we make the recipe 3 times. The first time we use 1 cup of sugar, the second time we use 4 cups of sugar, and the third time we use 20 cups of sugar. Since the recipe calls for 3 times the amount of water as the amount of sugar, we would need to multiply each of these by 3 in order to determine how much water we should use. The result is 3 cups of water, 12 cups of water, and 60 cups of water respectively. Finally, the amount of lemon juice according to the recipe should match the amount of sugar. This means we will use 1 cup of lemon juice the first time we make the recipe, 4 cups the second time, and of course 20 cups the third time. Of course, there are infinitely many other combinations of sugar, water, and lemon juice you might use and still follow this recipe. Let W equal the amount of water used making this recipe and S equal the amount of sugar used making this recipe. Which of the following can be said about the relationship between W and S? Notice that W, the amount of water used, is always 3 times the amount of sugar used. So A, W equals 3 times S is correct. Notice also the ratio between W and S, or W divided by S, is also always equal to 3. In fact, W over S equals 3 is equivalent to the equation W equals 3 times S. Finally, let's examine letter C. If S is multiplied by a certain number, W must also be multiplied by that number. To get from combination 1 to combination 2, we might multiply the amount of sugar used by 4. Notice that means we should also multiply the amount of water used by 4. In fact, this is what is meant by quadrupling the recipe. Similarly, to get from the second combination to the third combination, we might multiply the amount of sugar by 5. Notice the amount of water and the amount of lemon juice is also multiplied by 5. So it does appear that if S is multiplied by a certain number, W must also be multiplied by that same number. Since A, B, and C are all true, the answer to this question is all of the above. The relationship S and W have with one another is a special one. To describe it, we say that S and W are proportional to one another. Furthermore, the number 3 is their constant of proportionality. Let's formalize what we mean by proportional. Variable quantity A is proportional to variable quantity B when there exists a non-zero constant C such that A equals C times B. In this case, C is called the constant of proportionality. Note that is exactly the relationship that W and S have in the example above. The variable quantity W always equals 3 times the variable quantity S. Thus, W and S are proportional with constant of proportionality 3. An alternative definition of proportionality states that 2 variable quantities are proportional when their ratio is always the same. That is, whenever you take one of the quantities divided by the other, you will always get the same constant. We saw this in the example above too. W divided by S always equaled 3, no matter what combination of ingredients we were using. The reason this works as an alternative definition of proportionality is because the equation A over B equals C is equivalent to the equation A equals C times B. You could get from the first to the second simply by dividing both sides of the equation by B. Example 2. In which of the following circumstances are the variable quantities distance and time proportional to one another? A. You are traveling through a town with lots of stoplights and different speed limits. During this circumstance, you are likely to be stopped at a stoplight for at least a little bit. During that time, the ratio of distance to time will be 0 miles per hour, because 0 divided by any non-zero number is equal to 0. When you are not stopped at a stoplight, the ratio of distance to time is some non-zero number, perhaps 25 miles per hour. In any case, the ratio between distance and time is not a constant. Therefore, distance is not proportional to time. Let's consider example B. You are cruising at a constant speed of 60 miles per hour. In this situation, the ratio of distance to time is equal to the speed of 60 miles per hour. Note that since the speed is constant, the ratio between distance and time is a constant. This means distance is proportional to time. Note for both Part A and Part B, we use the alternative definition of proportionality to determine whether or not distance is proportional to time.